channel Gaurang the Motivator. Today we are going to discuss on the topic resistance. Before we begin the topic resistance, I would like to explain you a small basic concept of resistance. My dear students, you can find here two pipes, right? One pipe is a straight pipe. Okay, let's take it as pipe A, and the other pipe you can find it as zigzag pipe. Okay, let's take it as pipe B. Now my question is, when you pour some water through this pipe, okay, from which pipe do we get the water first? Okay, on the other side here, do we get in the pipe A or do we get the water first in the pipe B is my question. Of course, you all will say that from the straight pipe the water comes out first, and here it takes time, because as you flow the water it has to fill up to this level, then flow here, again it should fill up to this level, then go here. So this reduces the flow of water, correct? For speed of water. So now here the water flows fast, but here there is some obstruction, okay? Obstruction for the flow of water. The obstruction for the flow of water is the shape of zigzag, right? So the water comes out first in the plain pipe, and the water to come out from this pipe requires a bit more time as compared to pipe A. Okay, now let me ask you a question. Among these two pipes, which pipe has the ability to oppose the flow of water, whether it is pipe A or pipe B? Okay, I repeat my question. Which pipe has the ability to oppose the flow of water? That is pipe A or pipe B? And generally your answer will be pipe B, because here it opposes the flow of water due to this zigzag shape of the pipe. Whereas here the opposing force for the flow of water is not there, because it is a plain pipe, right? Moving on to the definition of resistance. Resistance also is defined in the same way what I have explained you this concept about two pipes. Okay, so here is the definition of resistance. Resistance says that the ability of a conductor to resist or to oppose the flow of current in it is called resistance. Okay, so once again I repeat, the ability of a conductor to resist or oppose the flow of current in it is called resistance. The SI unit of resistance, okay, is ohms. The SI unit of resistance is ohm, represented by a symbol which is called as omega symbol. This is omega symbol, and the SI unit of resistance is ohms. So this, if any conductor has more resistance, then the flow of current will be generally very less. If the flow of current is more, then we can say that particular conductor has very low resistance. Okay? Resistance also is defined with one more definition. Okay, so what is that definition? It's here, the ratio of potential difference. Okay, what do you mean by ratio? Ratio is referred to division symbol. Okay, so let's write here, resistance is defined as ratio is division symbol, ratio of potential difference, okay, across the ends of the conductor. R is equals to V potential difference, okay, across the ends of the conductor, that is across these two ends. If you have the potential difference only, then flow of charge is there. We have already studied in electric current topic. So the ratio of potential difference across the ends of the conductor to the electric current, R is equals to V divided ratio of potential difference across the ends of the conductor to the electric current that flows through it. Okay, so R is equals to V by I. So we can write here where R is resistance in ohms, okay, resistance in ohms, and V is potential difference in volts, okay, and I is electric current in amperes. So this is the other definition of resistance. My dear students, in board examinations, generally a question is asked, that is, define the SI unit of resistance or define 1 ohm. Here's the question. Define the SI unit of resistance or define 1 ohm. Suppose the question is define the SI unit of resistance. You are going to write first the SI unit of resistance is ohm. Okay, the SI unit of resistance is ohm. Suppose if they ask the question define 1 ohm, then we should start writing directly the definition of ohm. Okay, so let's see now what exactly it is. We know, we just stated that resistance is the ratio between the potential difference and the electric current. Okay, so R is equals to V by I. So here we can write that resistance, the unit of resistance is ohm, correct? The unit of resistance is ohm, okay, or we'll write it in words. Let's ohm, and the SI unit of potential difference is volts, so we'll write volts, and the SI unit of current is ampere, so we'll write here ampere. So from the formula of resistance, it's easy to define ohms. So how we can define? See here, just place 1, 1, 1. Okay, so if 1 volt of potential difference is created between the 2 points, okay, and 1 ampere of current flows in that conductor, then we say that the resistance of the conductor is 1 ohm. I'll repeat it. If 1 volt of potential difference is created between the two end terminals of the conductor, and if 1 ampere of current flows in the circuit or in the conductor, then we say the conductor has 1 ohm resistance. There might be some confusion if I say the definition orally, so I have written it here. If 1 ampere of current flows through the conductor, let's take a conductor here. This is the conductor, okay, a copper wire. If 1 ampere of current, so we can write the flow of current, okay, if 1 ampere of current flows, okay, so this current is 1 ampere. If 1 ampere of current flows in the wire or through a conductor, okay, on applying 1 volt of potential difference, the potential difference between these, how much we are giving? Using the cell, we are going to give the potential difference, so that will be 1 volt, right? The potential difference will be 1 volt. When we give the potential difference 1 volt and 1 ampere of current flows through this conductor or the copper wire, then the current is said to possess, the conductor is said to be possessed, okay, the conductor is said to possess 1 ohm resistance. Now, a very important question in the board examinations generally is asked, that is, what are the factors on which the resistance of a conductor depends? What are the factors on which the resistance of a conductor depends? Okay, so let's move on to this concept one by one. Number one, okay, so the first concept is length. Okay, the first factor on which the resistance of a conductor depends is length. Here, resistance is directly proportional to length. Resistance is directly proportional to length. Okay, what is the meaning? Suppose we have 2 copper wires. Okay, the length of the first copper wire AB is small, less, and the length of the second copper wire CD is more. So among these two, the resistance is more for the longer copper wire. Means if the length is increased, then what happens? The resistance also increases. So that is what it is meant. Resistance is directly proportional to length. Second concept, area of cross section. Area of cross section. So how is this related? Area of cross section. Resistance is inversely proportional to area of cross section. Resistance is inversely proportional to area of cross section. What do you mean by that? Now let's take a thin pipe, okay, conductor, and we have one more conductor, that is, this is another conductor which is thick. So let us take it as A and B. Now here, as the area of cross section is more in the case of this B, okay, so what it is thick, what happens? The resistance will be less. Inversely proportional means resistance will be less. But in this, it is thin copper wire. So what happens here? The area of cross section is very less. Because of that, what happens? The resistance will be more. So as you increase the thickness of a conductor, okay, the resistance will be going on decreasing. This is the second factor. Third factor on the factor, okay, the third factor is the temperature. Resistance is directly proportional to temperature. Means if temperature increases of any conductor, then the resistance also increases. And what happens? That particular time the flow of current reduces. So when you start heating a rod, what happens? Due to that heat, temperature is increasing, and due to the increase in temperature, what is happening? The resistance also is increasing, and due to increase in resistance, what happens? The flow of current reduces. And the fourth factor is nature of material. Okay, so we use different types of material. So the factors on which the resistance depend is also this is also one of the important factor, that is nature of material, because in some we use tungsten, in some we use tin, in some we use lead, in some we use copper, some silver, iron. So different metals we are using, and each metal has its own resistance. So because of that resistance, we say that this is the fourth factor on which the resistance depends, that is nature of material. My dear students, in my next session I will be taking about how can we connect these resistance. There are two ways of connecting resistance, one in series and one in parallel. So we'll be talking about resistance in series and resistance in parallel. Okay? Still then, stay tuned to my channel Dorang the Motivator. Please subscribe, like, share and comment. Thank you.